Hello, I'm Daniel Frankel, regular contributor to Stream TV Insider and the founder editor chief of Next TMT, which covers technology, media, and telecom. Real pleased today to be talking to Viliveiko Mettila, the head of multimedia at Nokia. You have been for quite a while. You've seen a massive evolution of video in your time there. Nokia has been the ground floor of developing video codecs, compression standards that enable us to pass around very high density files around the internet. We wouldn't be able to stream video without it. Today we're going to talk about the latest iteration of video technology, VVC, versatile video coding, Nokia's role in it, and how the company sees it benefiting the video ecosystem and how adoption will happen. So, how are you doing, Viliveiko?
I'm doing fine, thank you. I hope you're also fine. And thank you for having me on Stream TV. It's a pleasure to be here and also to have the opportunity to talk about the exciting developments in video standardization.
So this has been a long road. You've been VVC is also called H.266. You were part of the team that developed H.265, the predecessor, and the H.264 before that. Just briefly tell us, what these technologies are and how vital they are to the video ecosystem, what they do for us.
At Nokia, we have a long kind of 30 or even more years kind of background in multimedia standardization, and video codec standardization is one kind of key domain for us. And you're right that we started from AVC, so Advanced Video Codec. We standardized that in 2003. And then later we moved to High Efficiency Video Codec, HEVC, so H.265. And that we then finalized in 2013. So there's quite often this kind of 8-10 years kind of required to develop the new codec, because we also have a very strict requirement for the new technology when we standardize it. And then the latest standard comes from 2020. That is then VVC, or Versatile Video Coding, H.266. And that is now the latest codec which is coming to the market. So really long background, lot of kind of technology evolution between these codecs and getting more and more advanced when we are moving to newer standards.
My understanding is H.265, high efficiency video coding, was very well situated for the evolution and adoption of 4K. And now that we have that as kind of a mainstream commodity, the next focus is on 4K being even more ubiquitous and 8K distribution starting to take hold. And for that, you need even higher compression capability. VVC is being touted as the next major leap forward in video compression. Maybe you could tell us what the benefits are compared to previous standards and how it will contribute to a better user experience.
Versatile video coding, so VVC, also known as H.266 from ITU-T side. So it truly represents a significant advancements in video compression technology compared to its predecessors. So HEVC, VVC offers approximately 50% better compression efficiency, meaning that it can deliver the same visual quality at half the bit rate. And if we think that about 80% of all traffic in IP network is video, so such compression efficiency can have a huge kind of global impact. And this leap in efficiency then translates into several tangible benefits, and benefits for both service providers, but also for end users. And of course, enhanced streaming quality being one. So VVC enables smoother playback of high resolution content, so content like 4K or even up to 8K, but also content with HDR, so high dynamic range, having deeper colors, providing deeper colors, or even with for virtual reality videos or 360-degree video. and can do this smooth playback even on constrained networks. So nowadays, so many of us consume content on our mobiles. So overall, the new codec reduces buffering and improves the overall viewing experience. So then it also brings broader device compatibility. So it is very true to its name. So VVC, it is versatile. So it supports a wide range of applications. So applications from smartphones and tablets to smart TVs and VR headsets. And doing so also ensures consistent quality across all these platforms. And then if you think about content providers, of course, VVC reduces CDN, so content delivery and storage expenses, which is important. While for users, it means less data consumption, especially in mobile and bandwidth limited environments. And perhaps the last thing is that PVC is also future-proof. So with support for advanced features, so features like adaptive streaming, so your streaming experience can adapt to your network conditions. It is also has tools for screen content coding, so we can do very efficient coding, or for example, synthetic content like games. So sharing and watching multiplayer games is very popular today. Multi-view video is also one very exciting kind of application feature. So for example, stereoscopic imaging, which creates much more immersive kind of viewing experience. And then also low latency video, so which is important, for example, again in gaming, for example, in cloud gaming. So latencies are, and low latencies is a kind of must there. So, I mean, consider all these advanced features. So VVC is designed to meet these demands of the new emerging use cases. So whether it is immersive media or cloud gaming.
What are the biggest hurdles and opportunities driving the industry-wide adoption of the codec at this point?
So if you think about opportunities, so of course, firstly, we have this bandwidth efficiency at scale. So VVC's ability to halve bitrate requirements without sacrificing quality, it is a true game changer for streaming services, which then aim to deliver, let's say, 4K content or even 8K content, and doing that efficiently. There are also organizations like DVB here in Europe and then ATSC in the US. These are broadcasting kind of standards, and which then have embraced VVC and are rolling it into use in broadcasting. Also, of course, one great opportunity is that there exist great open source software tools for VVC. One very nice example from Fraunhofer. So software is available that you can take into use, and also kind of having commercial rights to take them into use. And then perhaps the last kind of opportunity here, that cost benefits and environmental benefits. So this kind of reduced data transmission not only lowers operational costs, but also contributes to sustainability goals by decreasing energy consumption. So these are all very great opportunities, but there are also challenges. And the hardware readiness today is one key challenge. So while many chipsets and TVs are technically capable of supporting VVC, so firmware and driver support still remain inconsistent. And of course, mobile hardware integration is particularly lagging still today. But then it's also good to notice that this kind of adoption lag for new technologies and new fundamental technologies like VVC. So industry experts know that codec transitions typically take up to a decade. So many providers are still transitioning to HEVC, so to the previous standards, and the business case for moving beyond is still evolving.
Let's talk about standardization a little bit. In an earlier conversation, we talked about the differences between open standardization and closed ecosystems. Uh, what are the benefits of open standardization, and why is it important in a video service?
Open standardization, it refers to the kind of collaborative development of technical specifications which are then publicly available and can be implemented by anyone. And in the context of video services and more broadly even, it offers several key benefits. Interoperability, of course, being key benefit. So open standards, they basically ensure that products and services which come from different vendors and can work seamlessly together globally. And this is crucial in video services where content must be delivered across diverse devices, platforms, and networks. So in a way, open standards enable technologies to scale globally. And so also content providers can reach global audiences without needing to tailor solutions for each ecosystem separately. And this naturally reduces complexity and cost in a significant way. But then also this kind of innovation acceleration is important aspect to notice. By providing a common foundation, open standards, they allow companies really to focus on the key differentiation and the key innovations rather than always needing to reinvent the field. And this fosters much healthier competitive environment overall. Moreover, cost efficiency, that is important aspect. So open standards, they reduce licensing fees, and you can also avoid kind of vendor lock-ins, making it easier, especially for smaller players, to enter the market and to compete on the market. So in a way, I would say that this democratizes access to technology and encourages diversity in offerings.
So innovation seems like the key here in a world of competing standards. Open standardization is a more powerful driver of innovation in your view.
It is a very powerful driver of innovation, and especially for global media streaming. In a kind of fragmented landscapes of competing standards, so I think open standardization stands out as a very powerful enabler of innovation, and for several reasons. One being this kind of collaborative development. So open standards, they are shaped by diverse stakeholders. We have academia, we have industry leaders, we have startups and regulators all together and bring together a wide range of expertise and perspectives. And this leads to more robust and future-proof solutions as so many views being taken into account in the development of standards. And as open standards are accessible to all, they also tend to gain traction much faster. And of course, this can create a very vibrant ecosystem. So, I mean, ecosystem of tools, services, applications, which are then built on the standard, and all this then accelerating innovation. Then, in contrast, if you think about closed ecosystems, so they often tend to lead fragmentation, where innovations are locked within the proprietary platforms. And what we want to do with open standardization is to break down these silos and allow ideas, technologies to flow freely across the domain. I think that is very important. And it's important because media streaming is inherently global. So open standard ensure that content, it can be delivered, it can be consumed across borders without any kind of technical barriers. And this can, of course, foster cultural exchange and market expansion overall. Very important things indeed. And also one thing it's good to note is this kind of strategic shifts of individual companies, which may happen. So company may support the technology and later drop it. And I would say that open standards are much less vulnerable to these kind of shifts because they provide a very stable foundation that the industry can rely on, and even as technologies evolve. So in a way, as they also level the playing field, they encourage competition and encourage competition based on quality and performance, user experience, rather than exclusivity or control. And this is much better outcome for consumers and also means faster technological progress overall. So in kind of essence of a standardization, I would say that it transforms competition from a race to dominate into a race to innovate. And I think this is very important with open standardization.
Well, especially now, it seems like the acceleration of new technologies is kind of gone to 11. And I was reading my notes. There are enhancements related to AI, neural network based post filtering being one of them. Let's talk about that a little bit and what its relationship to VVC and what you're doing with it.
Happy you picked this up. So it's a very recent, very exciting new topic. And also this neural network-based post filter. So it's something we very recently standardized. Now something which is then introduced into the video coding ecosystem, and it's introduced through the versatile supplemental enhanced information standard VSCI. And this is actually the first time, really the kind of first time AI has been formally integrated into video coding standards, so standard like VVC. And then if you think about how it works, so this neural network-based post filter, it operates as a kind of post-decoding enhancement layer or step. So after a video is decoded using a standard codec like VVC, so neural network is applied to the decoded frames to, for example, enhance visual quality of the video by reducing kind of compression artifacts. And in our evaluations, so this corresponds to roughly 8% compression gain, which is very nice result indeed. But you can also apply the filter to, for example, upsample resolution of your content. So moving up from high definition to ultra high definition, so 4K content. You can also increase the frame rate. So going up from 30 up to 60 frames per second, for example, so having much smoother playback. You can also expand the bit depth for, say, richer colors. So having deeper blue, red, and green colors. So many nice benefits what you can achieve with this kind of post filter. And also the nice kind of aspect of this standard and this technology is that it is adaptable across codecs. So in a way, it is codec agnostic design what we have here, because since the filter is applied after decoding, it doesn't require changes to the codec itself. So you can keep your current existing system, your current codecs, and apply this as a kind of additional technology to enhance the quality. And this makes it compatible with multiple standards like VVC, HEVC, and so on. And very unique aspect of this technology is that you can also do content-aware fine-tuning on the go. So the neural network can be fine-tuned per content segment at the sender side. And then these updated weights or parameters of the neural network can be transmitted to the receiver side to be then used for the filter when the video has been decoded. And we'll be also working on a quite unique new standard called neural network compression at MBEC, which can be used to compress these parameters, these neural network weights, so that we can achieve very efficient way when we transmit these neural networks over communication networks. And this fine-tuning really kind of ensures optimal performance across diverse content types. And then finally, this kind of backward compatibility is also should be noticed here that of course there are always devices that may not support such neural network pulse filter, and that is okay because you can still decode the base video stream without the filter. So in a way, ensuring graceful degradation.
So how long? Where are you in terms of adoption of these new technologies? I mean, you've seen cycles across a couple of different epochs. How long does it take? Is it a decade proposition? Less than that before it's in every smart television, smartphone, every video device?
If you think about video codec standards, it typically takes a kind of decade or let's say 7-8 years to really adopt the new technology. And these are truly foundational technologies and standards. So this been our kind of experience from the past. And then also therefore, we always kind of develop the new standards every 8 to 10 years. So that to provide the new technology for new use cases. For example, with AVC, the kind of driving new use case was high definition kind of video at that time. And then, for example, with HVC, we moved to 4K content, so ultra high definition. And for example, now the latest codec, it is versatile as the name says. So it can provide very efficient compression, for example, of synthetic content for game playing. So really driving kind of new use cases. So each codec generation can target new emerging use cases.
So are you all already working on H.267 at this point, or what's you're not done with this? You have to support it, but where are you with the next generation?
So we are exploring again a new codec standard, and exactly it could be named as H.267. That is the name coming from ITU-T side, and again having new use cases in mind. So the multimedia field is continuously developing, and companies are really kind of racing to introduce new multimedia experiences and services. And this is also why we need to develop new technologies to support these emerging use cases, whether it is, for example, virtual reality video, or whether it is, for example, cloud gaming, where low latency video is crucial.
Well, it's a lot of very complicated but fascinating stuff. Again, you've been on the forefront of it, and it's been a pleasure to talk about it a little bit with you today and learn about it. So thank you for sitting down with me, Vildenko, and look forward to hearing more about VVC in the future.
Thanks again for the opportunity to join you today. It's been a great conversation, and I really kind of appreciate the chance to share our perspective on the future of video standards and their development. Thank you.